Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some problems from homework 2.1. So, a little change up now. What we're looking at here is we're looking at, let's see if I put it, yeah. So we're looking at domain and range, relations, functions coming up real quick here. Let's start with a kind of an easy basic idea. It says use the set of ordered pairs to represent the relation as a map. So a relation is just basic. I guess the basic definition of a relation is that it's an element in one set, in our context would be x values, corresponds to elements in a second set or output set, which are the y values. So we're trying to figure out which one of these maps makes sense. And I'm going to first show you the ones that don't, just so you can see. The right answer is at A, but I want you to see how these maps kind of get messed up at the beginning right away. So what we're going to do is we're going to make the red the first x value. So x is the first value, and it corresponds to the y value. So red. So let's do that. And by the way, we're going to start using the name domain. And domain is the set of all x values. And so what this particular map at C is saying is it's saying that, well, it's backwards, because we always start with x, and then go to y. X is the input, y is the output. And this is in reverse order. So you notice the arrowhead's going the wrong way. So that's not going to work. Let's try the next one. The next one says, option B, there's my 2, right? And its relation or correlation goes to 3. And this 2 goes to 12. So that's not going to work. So we know the answer's got to be A. But let's see. Okay, we start with red 2. And according to my ordered pair, it says it goes to this green 3, and it in fact goes to this 3. Now let's just get used to calling the collection of all x values or input values called the domain. And the collection of all y values, or in this case, or output values, in this case y values, is called the range. I'm going to get used to calling the set of all x values the domain, the set of all y values is the range. Let's see if the other particular problems work out. I start with 5 in my x, and according to the ordered pair, it goes to 7. And 5, in fact, does go to 7. Next problem, I start with a 7 in my x, my domain, and it goes to 7 also, it looks like. Yep. And that's what the map says. And that's what my ordered pair says, so we're good. And finally, we've got an x in the domain 10, and it goes to 12 in the range, and that's exactly what happens here. So, of course, the answer is A. Next problem. It says the blank of a relation is the set of all inputs. Well, the domain is the set of all inputs, in this case x values, and let me do this to highlight it. Input values, in this case, are their x values, and it says the blank is the set of all output values of the relation, and the range is the set of all output values. In this case, we're talking y values. Okay, so that, let's see, do we do it? Range, there it is. Got to bubble it in. Next problem, state the domain and range of the relation. Once again, a relation is just is when you have a correlation between the input x and the y output. And ordered pairs show a correlation, and equation actually shows a correlation. So equation is a relation as well. Let's go through and figure out the domain, which is the set of all x values. Looks like I got a -5, a -4, a 0, and a 1. -5, -4, 0, and -1. Okay, this is the domain. Now the range is the set of y values, or the output values, which is going to be 4, -4, -5, and 4 again, and you don't have to rewrite it. So 4, -4, and -5. I checked it, and MyLab takes that as an answer that way, and you could also write it in ascending order from smallest to largest, -5, -4, and +4 if you wish. Next problem, number 4. Looks like this homework set's going to go faster. I think we kind of need that at this point. Identify the domain and range of the relation shown in the figure. So a relation also could be shown on a graph, right? Because it shows relationship or a correlation between x and y, or input and output. So I think what I need to do is I need to label these points. Looks like I've got 2, 5, and I've got 4, -1, and I've got 0, nope, this is 0, 0. And I've got -1, -4. I've got -5, -1. And I've got -5, +3. So -5, +3, -5, -1, and -1, -4, 4, -1, 0, 0, and 2, 5. Okay, like we said before, the domain is the set of all x values. So if we go through and look at all the x values, I'm just going to go from left to right because that just puts it in order for the x values. Remember, x is the horizontal. So we got -5. We don't want to double write that down. -5. Then the next one is -1. Then I've got x equals 0 in that case. Then I've got a 2 for x. And finally, I've got a 4. So -5, -1, 0, 2, and 4. Now the y values. The y values, if I start down here, it's a -4. As I'm moving up, I see a -1 here and a -1 there. You only write it once. Then I see a y value of 0, a y value of a 3, and finally a y value of a 5. And that is your range. Now, something to remember. This graph is discrete, meaning it's not continuous, it's not flowing. When I plot it, I have to pick up my pencil and put these specific points. A discrete graph, in this case, look at, we have a countable number of solutions, right? And so it's listable. There's only 1, 2, 3, 4, 5 domain x values in the domain, and 1, 2, 3, 4, 5 y values in the range, and we can definitely list that as discrete. Now, when we go to the next problem, you may think you can list this, but the fact is, because it's connected, even going from -4 for x to 0 even, or 2, there are infinitely many real numbers in there. Way too many numbers to list. So you're not going to be able to list it. So we have to remember that there's some ways of showing that. And one way of showing that is using interval notation. And another way of showing that is using inequalities, or you can see right here, looks like they're using set builder notation. So we're going to use set builder notation. Identify the domain and range. The domain is the set of all x's such that, and then we just write our inequality right here. Our inequality. So remember, our domain is the set of all x values, and x values go left and right. So I'm going to make a mark right here. looks like that's my smallest x value, which is -4. And that goes up to my biggest x value, which is 8. So we're going from -4 to 8. Now if it said put it in interval notation, it'd be nice. You'd have to include -4, it's closed, and it's closed at 8. You'd be done. But it wants it in set builder, so we need to write this as an inequality. So it goes from -4, so we say x is greater than or equal to -4, and x is less than or equal to 8. That is the domain. Now range is the set of y values. And I think I'm going to erase this so I can get a little bit of clarity on that part. So the range is this set of y values. What's the smallest y value that's represented on this blue ellipse? The y value is 1. And it goes on up to the biggest y value on this graph, on this ellipse, 3. So it just goes from 1 to 3. Notice the domain used x because it's x values. For the range, it's y values. So we're going to make our range, and if this was interval notation, we'd say it goes from 1 up to 3 and it's closed. But they're asking us to do it in set builder, so the set of all y is such that y, so we go y is greater than or equal to 1, and y is less than or equal to 3. So A is the solution here with a fill in the blank, and A is the solution here with a fill in the blank. All right, what's next for us? Number 6, identify the domain and range of the relation from the graph. What is the domain in set builder notation? Select the correct choice below. So once again, now my only complaint here is they should have put little arrows on here showing that this goes forever, because that's what they intend. Let's talk about the domain. Once again, the domain is a set of all x values. Now that blue graph, that blue line, in terms of its horizontal, it goes for the left forever, and it goes for the right forever. So this would be all reals. With set builder, we don't have a way to show all reals other than the fact we just say the domain is the set of all real numbers. So the answer is B. And the range, let's take a look at the range now. The range is the set of all y values. So this blue line goes forever down, down, down. So it's going forever down. And then it goes forever up, 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 up to the right, but still up. So this is also all reals. B. The range is a set of all reals. And let's go back and say, yeah, and so is the domain, all reals. Was forever left and right and forever up and down. Same thing, let's figure out what the domain is. And this time, write your answer in interval notation. Oh, thank you. So the domain is the set of all x values. And you can see this blue parabola goes forever up and to the left. So it's eventually going forever to the left. And it's going up and forever to the right. And so we're going forever to the right. So this is all reals for the domain. How do you write all reals in interval notation? Well, you go to negative infinity out here, and you go to positive infinity out here. So it just is negative infinity to positive infinity, and it's open. You cannot close or include infinity. Now the range is the set of y values. Y values are up and down. The smallest y value I can see on this blue graph is right there. And that looks like -5. And it is including -5. And it goes all the way up. Well, it goes forever up, so it goes forever up. So if we were going to write this, the smallest y value on this range is -5, and it goes forever up to infinity, and -5 is closed. I was just sort of testing, putting different things into my lab, and wait a minute, let me go back here. Ooh, I can't see very well. It looks like that is -5, -6, -7. Let me make that correction. That is -7. So let me fix it here. So the interval notation goes from -7 up to infinity. And let me fix it right there. -70 to infinity. It's closed. So in the infinity symbol is on. Once you click on that fill-in box, it'll show you a sort of keypad or extended keypad that has infinity on it. You can use that there. I don't think it has brackets, so you're going to use the bracket on your keyboard, and you're going to use the parenthesis on your keyboard. Okay, so next up, number 8. Use the graph of the relation. I'm going to just talk about that relation again real quick to find it for you. Remember, what is a relation? I already said it a couple times, but a relation is when you have elements in one set, or the inputs, or in this case the x values, that corresponds to elements. Why am I having a hard time writing that? That corresponds to elements in another set, which is the outputs. In our case, y values. Okay, so many things can be a relation. Relations is not hard to be a relation. Well, you have to have a correlation between the x input and the y output. So, but we have many things that are relations. These graphs are the ordered pairs, stuff like that. So, use the graph of the relation shown to the right to identify the domain and the range of the relation. So finding the domain and especially finding the range when you're just looking at an equation takes some work. I mean, something to note though, if it's a linear equation, not all lines are going to be all reals for the domain, all reals for x. But most lines that we see that have some sort of slope to them, not verticals, not horizontals, are going to be all reals for the domain and range. Let's take a look at this one and see if we kind of mentally figure that out again. Remember, the x values would be the domain, so the domain is a set of all x values. Now, does this go forever to the right? Well, this blue line goes down and to the right forever, so eventually it's just going forever to the right, which is positive infinity. And it's going up to the left, so eventually it's going to go forever to the left, so negative infinity. They want interval notation, so we're talking negative infinity to positive infinity. This is all reals. I need a sip of water. Okay, now we've got our range. Our range is the set of y values. And this is just because of orientation of this blue line, it's probably easier to see that the y values are going forever up, 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 and forever down, down, down. So y values are all reals also, and with interval notation, it goes from negative infinity to positive infinity, and it is open. And when you learn how to write infinity signs, the first time you feel like you have to sort of lay sideways and just make an 8. But anyhow, you get used to it. Although mine look pretty sloppy there, though. Let's go to the next page. the next and last page. Awesome. Draw the graph of a relation whose domain is all real numbers, but whose range is a single real number. So this one, we're talking about what? The domain. Domain is all reals, and range is a single real number. Well, if we go through here, I'm looking at this range, and it starts at 0 and goes forever up, so that's not a single number. This range starts at whatever that is and goes to whatever that is, but that's definitely not a single number. That's many numbers in there. This value looks like a single number. This value for the range, right, y values, goes forever up and forever down. So that has a range that's a single number. In fact, that number is 2, 4, can I even see that? 5, I believe. It's like possible to see. You could actually list that, but the domain, on the other hand, I wish they put arrows on this thing consistently. The domain goes forever to the left and forever to the right, so that domain is going to be all reals. And that's what they said. Find the relationship whose domain is all reals and whose range is a single real number. So our answer is C. All right, down to the last question. Write each relation as a map, then identify the domain and range of the relation. Okay, we got to figure out which one of these things map. So, of course, we'll go with our -8. We got to be able to find -8. And I don't even see a -8 in this domain, so that's not going to work. There is on option B, there's a -8 there. What does this guy go to? -5. And it does, -5. -5. -5. What does it go to? It goes to -2. And it certainly goes to -2. So far, so good. Getting excited. 3. According to this ordered pair, 3 has an output of 6. Looking good. Then we have 6. It has an output of 9. Whoops. That didn't work. Let's see, I'm just going to copy B. Let's see, -5 went to -2. Gosh, almost got screwed up there. So -5 goes to -2. Looks good. +3 goes to 6. +3 goes to 6. Good. Okay, -8 goes to -5. -8 goes to -5. That looks good. You can see it right there. I better go back to the ordered pairs because this is where the other one started messing up. 6. And 6 goes to 9, and 6 goes to 9. So far, so good. This has got to be the right answer because there's only one left. 12. 12 goes to 15. 12 goes to 15. Once again, this is the range. And the range is the set of all y values. And the domain is the set of all x values. And it looks like part C is the answer. Now they want us to list them out, so let's do that. The domain, -8, -5, 3, 6, 12. Range, -5, -2, 6, 9, 15. -5, -2, 6, 9, 15, and the domain -8, -5, 3, 6, and 12. All right, we did it. This looks like Christmas. I feel like Christmas time in, September? Anyhow, I hope you are doing great. This is close to our last homework section, so we're on the home stretch if you're watching this. Take care and have a great day. Bye.